Welcome back, I'm Captain Xavier, and this is my Armat M56A2 Smart Gun. And this is going to be the how it works video. I'm going to open it up and show you all of the interior, show you how everything on the inside works, how it all interacts, and that way if you really wanted to make one yourself, you might actually be able to. I'm not taking commissions right now, and I'm especially not taking commissions for something this big. This took me 3 months and probably 100 hours to build. You don't want to know what that would cost. So, let's get it open. It is having a couple of minor issues that resulted from some last minute things that I had to do, so I needed to open it up anyway, and so this is the perfect opportunity to do so. So, it does in fact come apart into two pieces, not super easily, but the barrel is removable, which breaks it down into two 2-foot sections instead of one 4-foot section. So we're going to start with that. There are 4 screws that hold this front assembly in place. 2 of them are through 3D printed sections that I had to kind of custom modify, and then there's supposed to be 2, but apparently I have a shorter screw. So there's one that's right here through a metal bar. There's a lot of metal parts supporting the integration in here because I prefer metal and screws to epoxy and glue. Alright, now that that is off, we should be able to pull this barrel section forward. It is well and thoroughly snug. Nope, that's not a load bearing section. Okay. I designed it so it would not fall off, but that also means it's somewhat difficult to take off. Okay. Then, what you will see in here are a whole bunch of jacks. And these are all of the wires that connect the front to the back. And we just need to unhook all of them. There are currently 5 of them. There will eventually need to be 2 more. And that then allows us to take the barrel section apart. So, a couple of screws. It then sockets over this little section, and then everything plugs in. We'll start with the front section, which is where the flywheel cage is, and it's definitely the simpler, as well as the main control grip. This is just a rocker switch, and all it does is connect signal wire. So there's no actual current passing through it, or not the full LiPo's current. It's just current coming off of the Arduino that passes through this switch. So when the switch is connected, it then completes the circuit, and that signal goes back to the Arduino, which then tells sends the signal to the ECSs to make the brushless wheels move. So that is simply a signal connector switch. This switch, which is a push in, push out, this will be the FPS limiter, as it were. So when it's not pressed, the FPS will be around 120. So HVZ level FPS for when I want to actually take this to, I would love to be able to actually take this to something like Afterworlds or somewhere that has, approximately a 120 FPS limit. And that's what it'll be when that's not pressed. Pushing it will then light it up, and it will set it to whatever the max FPS is, which is generally around 150, which would be good for Nerf Wars, our local Nerf Wars. So that is the plan for that switch. I may eventually add more switches for more complicated things. If I wanted to have, to limit the rounds per second, though I don't imagine I would ever want to do that. But there are additional locations for additional switches. I would love to get my hands on the actual original Kawasaki 125 AR, I think that's what it's called, motor group, or handle, which is what this is from. It's also what these are from. They were 3D printed and for mine, but the original ones, they were part of a motorcycle that they just bolted on to make it look fancier. And then the same with this handle and the back handle were both off of, I believe they were both off of that same motorcycle. Very hard to find those parts anymore because they've all been used for making smart guns over the last couple of years. Okay, let's get into the flywheel cage. which requires us to take off these, but that is not difficult as they are just screwed on. It is now raining, if you're wondering what that staticky noise is. I do have metal plates in here that just give a little more structure to this barrel segment, keep it from flexing in ways I don't want it to flex. We'll take off both sides. Oh, why is there water under there? That is somewhat alarming. Probably because it got on there. Okay. And then we have, this is the flywheel cage. And this was very much a custom design. The original design came from, I believe, NPN. Yes. I have my, my list of people to thank so I don't forget anybody, and I almost certainly still will. The original cage that I used, vaguely speaking, was from a design by NPN, link in the description. He has a fully 3D printed blaster that's very similar to a Hurricane. To Out of Darts' Hurricane, except it's entirely 3D printed and the stock is the tube magazine system, but it's a very similar concept. But it was a brushless motor system, so he had the cage size and he had the wheels, and that's what I needed, but I needed it to be shaped like this. And so I started with this file, and just using my slicer, created this file. Because I'm a madman, and the amount of time it took me to do that, I probably could have just taught myself Fusion 360 and done it that way, but I've gotten really good at not knowing how to 3D design. At this point, Sergeant Deplorable says that I am just using my slicer as a 3D modeling software, which is, I'm sure, horribly inefficient. It's kind of like trying to, oh, I don't know, forge the Mona Lisa in MS Paint. You could probably do it, but not the best way to go about it. But a lot of slicing later, I had the cage I needed. I have discovered that its tolerances are very, very tight. I had a couple of jams while doing filming where it was a rival round that it had gotten a little wet and had soaked up some water and swelled slightly, and so it wouldn't fit. It would get jammed in there because the tolerance for how small of or what size round will fit is very low. So I may end up taking this out and filing it out a little bit to try to give myself a little bit more space. But we have our brushless, or wheels. I'm using brushless motors from Out of Darts. I don't remember exactly which ones. It's the only brushless motors that he carries. And that's those are the wheels for that. So on the far side, and that'll give us access to the back side. Not a whole lot to see back here. You can see the pusher motor. It is one of those small 12-volt gearboxed motors, the same ones that are used as the pushers in the Jupiter. And so obviously, I mean, there was a lot that was, I don't know if this was his own design or if he very much was just copying both the Hurricane and the Jupiter when NPN designed this, but it is very similar. I had actually originally intended to just use a Jupiter, and in a bit of mind-boggling coincidence, the dimensions of this ended up being almost to the millimeter identical to that of a Hurricane. I could pull this out and put in a Hurricane and it would actually function with a few minor modifications. But I really wanted this to be brushless, so I went with brushless motors. I did have to then, the first cage that I made was designed to use a different motor than I ended up using. And the screw mounts on that motor were not symmetrical. One was slightly longer than the other, and this cage was originally designed for that. And so I was only able to put 2 screw mounts into those motors, and that obviously didn't work. And the material where the motor mounted was only like 1 or 2 or 3 layers. It was not enough, and it ended up breaking and having a catastrophic failure that fused one of the wheels to the side of the cage, which was bad. So I ended up redesigning the cage using Ultrasonic's Flywheel cage. So I took his was designed specifically for these motors, And so I cut the bottom of this cage out in my slicer and dropped in the bottom of his cage in my slicer and melded it all together. And it worked perfectly, and it has worked beautifully ever since. The motor was having a little bit of trouble of walking around and getting away, but I hot glued it in place, and it hasn't gone anywhere since. So that's where all the wires come in and go out. I did end up, I hadn't expected this to stick out as far as it does. You can see it sticking out there. And I had to redo the motor cover to create a little box motor cage cover for that. And I then had to Dremel a hole in there for that to fit over and cut a hole in there. But it all ended up working, and it does not detract from the aesthetic very much. I mean, if you didn't know to look for it, you wouldn't even know that anything had really been done right there. So that's the cage. The barrel is just a 2-inch square PVC. Turns out that's a thing you can order on Amazon. And I was very happy to discover that because obviously I needed it for the barrel. There is then a aluminum barrel inside. I don't remember the exact size, something like 1 5/8 or something. It fits nicely inside the PVC with just a little bit of a ring. So there is again, on either side of this flywheel cage, there is 3D printed section that extends out into the barrel, so that's obviously why it's holding together at the moment. And on this side, it's designed to have this socketed into it perfectly. That barrel sockets into that side of it. And then on the far side, to create the channel on the inside, where'd it go? There it is. To create, you can see there is an inner barrel there that the rounds travel through, and all the wires and stuff are around it. It is, in fact, the exact same material that Out of Darts uses for the magazine, the tube magazine stuff on the Hurricane. So that was another place where Out of Darts came in to make this possible, because he had sourced that material and I already had some from previously. And I designed 3D printed parts that slide in around it to hold it in place, that then keep the cables and all of that in line. The wires for the switch on the handle just come up out of the barrel there. That is one of the cosmetic differences from mine. In the one in the movie, the cable does still come out of here, but it's external, and it goes back to their heads-up display and their breastplate, and where there's supposedly a computer and all of that. I chose to run it all internally so it wouldn't get caught on things and get torn and all of that. It also made cable management just way easier. So that's pretty much everything that's going on up here. We then have just some cosmetic barrel greebles that are not nearly as centered as they should be, but I was in a hurry, unfortunately. There is a lot of, once again, metal reinforcement plates that are holding things, because just having this bolted into the plastic, it was way too wobbly. It's still wobblier than I would like, which is why I would love to get the original, the real one, that I could actually seriously bolt in, because there's just limitations to 3D printed parts. But that's really all that's going up in there. Brushless motors, the ECSs are in here as well, and I think I need to either reflash mine or replace them. I do have, the ones I got were apparently not the best, and they weren't the ones that were designed for the software that I'm using, and so there's some hinkiness going on in there, but I do have better ones. I'm also considering ordering slightly more powerful motors, see if I can't get a little bit more power out of it. I ended up getting the mid-range ones rather than the most powerful ones, because I didn't realize there was a drop-down menu to get different ones, or I would have. So that's pretty much everything that's going on in the front section. All right, for all of the wires, there is negative and positive going to the motors. There is the signal wires that go to the ECSs. There is the pusher motor, negative and positive, and then there is the rev switch signal wire. And the way they're currently set up, there is no way to plug them in wrong, because it doesn't matter which ECS goes to which on the other side. There's only one XT60, and then these two JSTs, one is negative, or one is female and one is male, so there is only one way to plug it in. When I go to wire this, I will either need to add some additional wires, or I'm going to need to label them somehow so that I can tell them apart. But it's a little crowded now. I'm not sure how I'm going to get 4 more wires. They don't need to be heavy wires because the light, while it's a 12-volt light, doesn't need much current, so it can be really light wire. And then the other 2 wires are going to be signal wires. So it'll be fairly small wire, but there's still going to be 4 more of them, which is just going to be interesting to deal with. Huh. Okay, so that's the front end. Let's get all this out of the way, and now we'll get to the real fun, which is the back end. So, obviously we have all of those same wires and socket coming out of this side, but there is then a lot more going on. So, first of all, let's take the battery out. The drum magazine on here is an actual MG42 drum magazine that I bought used, and it has been well and thoroughly mangled at this point. There's all sorts of holes and whatnot else drilled into it, but there is just a surface-mounted XD60 jack in there that the battery plugs into, and I have a number of 2200 milliamp or 2.2 milliamp hour 3S batteries that they all fit in there nicely. It then locks quite conveniently. Need to get this shroud better attached. It's just been tacked on with one screw, and I need to add at least a second one to hold it in place. But the drum is screwed on, again, using metal plates because it works. It's got a pair of screws down here that hold it onto a custom metal plate that I made. And then it will simply come off. The front part does use the original MG42's hook. And then I made the corresponding hook, again, fabricated it out of sheet metal. And that's what holds it in place. I could have tried to make, you know, a clip that would use the original locking clip, but that was going to be a lot more complicated, and I wasn't going to be taking it on and off very often like they would have with a real drum, so I chose to just permanently attach it. But then it has an XD60. There's a lot of XD60s in here, or there used to be. And that just allows me to disconnect it easily because of how often I had to open this thing up to tinker. Now we're going to take some stuff off of this side that is purely cosmetic or doesn't really need to come off, but it'll make it a lot easier to deal with the interior stuff without these attached. So the priming handle here on the side is purely cosmetic. It is just screwed in place and it doesn't move. But it looks neat. And so far it hasn't broken off despite being all 3D printed. It probably will at some point, and I will have to come up with a more robust solution, but in the meantime it still works, so I will continue to use it. We then also have the rotation plate, or the arm mount that is on here, which is just a caster wheel mounting. Took the wheel out, bent it in a little bit more to get it to fit, and then just screwed it on the side. And since it's got ball bearings, it's nice and smooth. It won't do a full 360, but it doesn't need to. It only needs to go, you know, 90 up, 90 down. But that will also get in the way of lying the thing flat, so we're going to go ahead and take the 4 screws that hold it in place out. Used a lot of these heavy sheet metal screws in this build. Okay, we then have the hose and the wire that go back to the backpack. So this hose really does just pass through here just so it can get to the barrel. I mean, I could have attached it somewhere else. I could have attached it even closer to here. Originally, it actually fed in through the bottom, through a hole here. But that 90-degree straight up and then a 90-degree bend there, the rounds are having trouble. We're getting stuck and not having enough pressure in the tank to actually push up around that corner. And it fires much smoother when the balls are rolling along a flat thing. However, it's slightly pinched right here. Which the balls will get stuck. If there's any pressure, they'll make it through, but I'd like to get rid of that. So that's one of the things that I'll be doing in here is dremeling the mag weld just enough to make that a little bit looser. And then obviously power. So when you flip the rev switch on the front carry handle, it toggles a MOSFET inside that then sends power to the backpack. So we'll get into how that works once we get inside. So let's continue getting this open. About half the weight of this blaster is in the drum magazine, by the way. This is not very heavy at all because it's all 3D print and plastic. The epiphany that finally led to this blaster happening. I've been wanting to build one of these for a very long time, but didn't have what I needed or wasn't prepared to try to do it how I thought it needed to be done, because I knew it was going to be a lot of work and wasn't going to look as good as I would like. Because originally my plan was to use a Nerf Centurion, because that was the closest thing I could think of that Nerf had produced that looked like an MG42 or an MG34. I'm pretty sure these were built. Yeah, these were definitely an MG42. Star Wars blasters, the early big Star Wars blasters were actually MG34s. But this part right here is the lever to swap out the barrels, which was on the MG42. So the Smartgun was definitely an MG42, and I think some of the later large Stormtrooper blasters might have been MG42s rather than MG34s, but it's largely a academic difference at this point. But I didn't think there was a good Nerf blaster to do it out of, and I was talking to Sergeant Armor about this project, and I was gearing up to do it. I was really like, okay, I'm gonna do it. It's gonna be a pain, but here's where I am for the plan so far. And he asked, well, why don't you just use the Star Wars blaster, the First Order Stormtrooper Deluxe blaster? And I had forgotten that was even a thing. And yeah, that one it's either built on an MG42 or it's built on an MG34, but either way, it was close enough that it was exactly what I needed. And thanks to the Nerf Curator, I already had one. I'd had one sitting in storage for forever, still in box. I hadn't decided what I was going to do with it. He gave it to me, and then it just languished because I didn't have a project for it. And then, Armor pointed out that I could just use that. Like, oh, and I think I started the project like either that day or the next day, and just ran with it. And it all started coming together way, way faster than I ever expected it to. So that was the kick in the pants that I needed. The fact that, okay, the blaster does exist and I have it. And then came a lot of plotting and planning and fixing and hemming and hawing. I searched Thingiverse and found that somebody on Thingiverse had in fact modeled the entire Smartgun. 3D modeled the entire thing. And that was Zagadka was the person who had modeled the entire thing up in and put the files out there. And he had conveniently cut it up into small sections so that you could print it on a relatively small printer. And I was able to fit the parts that I needed on mine. I had to slice a few more of them, but all of the ones that I really needed, I was able to. I had to, these were actually in two sections. You can see the seam right there, and had the whole barrel section and all of that in there, because his wasn't designed to be functional. It was designed to purely be a cosmetic thing. You'd print it, you'd glue it all together, and it would just look cool. But it wouldn't actually have any internals or anything like that. And so I had to do, again, a lot of creative slicing to slice off just these, slice off everything that I didn't need, and then I couldn't print them in one big piece. I didn't have a printer large enough for that, so I did print them in two sections and then glue them together, and then that was another reason for the metal to hold those together. And I worked out, okay, so this is the entire section of it that is, losing screw. This is the whole portion of it that is an actual Nerf blaster. This little section right in the middle, basically the receiver, is the only part that is an actual Nerf blaster. Everything from here back is 3D printed. Everything forward of that is either 3D printed or PVC or something like that. But I needed a hollow section that was very solid that I could mount the electronics in, the switches and all of that. That needed to be, one of the things I need to fix is I need to add a return spring on this trigger switch because, well, I'll get into that. Anyway, I needed somewhere where I could house all of that, and luckily this blaster looked enough like an MG42 that it worked. So what do we got going on inside? Well, first of all, we of course have the hose, which we are going to, we might remove, might not be able to easily enough to want to do it. No, wait, that's the whole point. Yeah, okay, it does come out easily enough. But as you can see, it's not entirely round anymore, and that will simply not do. Should be able to fix it easily enough so that rival rounds will roll through it smoothly again, or I will just replace this section, it's a short section, with a new section, but I need to Dremel out a little bit of space in here. But this should now let us lie flat, and I should be able to zoom in so you can see what's going on in here. We'll follow the circuit through. Power originally comes from the battery into this XD60 connector that comes out of the mag well on the side. It then goes into this big switch here. This is the primary on-off switch, and its current will be off. Flipping it forward turns it on. It's mounted where the original trigger would be because it is very conveniently covered. I don't have to worry about that accidentally getting bumped in the blast or getting turned off while I'm in the field. And that's important because this thing has an annoyingly slow boot up time, and that's something that I need to figure out what that is. And I'm pretty sure it's just in the code. The code is not optimized for a quick boot up, and I just need to probably talk to FDL and AirZone, and I've already talked to them, but talk to them about some optimization on that. But when you flip the switch, obviously everything powers up. The Arduino comes on, the ECSs come on, the motors make their boodly-doot noise. Power comes from this switch to a step-down converter that takes us from the 12 volts that are coming out of the battery to the 5 volts that the Arduino takes. I accidentally forgot to plug that step-down converter in once and blew up the first Arduino Nano that I was using. Luckily they come in a 3-pack, and I needed all 3 of them. So that's where power comes for the Arduino. There is then power coming off of it to this XD60 connector here, which goes to the motors. So they just directly have power directly go, or rather it goes to the ECSs. So power goes from there directly to our ECSs. And that's what makes them come on. And they then will trip over and send power to the motors as needed. Finally, power comes from here and goes to a small MOSFET board that is right here. We've got an Arduino Nano and a MOSFET board on a little custom housing that I created, again, in my slicer because I am a toolless monkey. But it's nothing but rectangles, so it was really easy to just measure what I needed with the calipers and then just slice together a bunch of rectangles. Works beautifully. But power goes into it, and then that gets tripped by the MOSFET. Or rather, the MOSFET gets tripped by the Arduino. So when you push the rev switch, here in the flip, when you flip that, not only does it then tell the Arduino to send signal to the ECSs to make the motor spin, it also tells one pin here to become high, send out 5 volts and probably an amp, that then gets sent to the MOSFET board. Because the MOSFET board, in order to trip it, there's 2 wires that come out, and when that circuit is completed, it trips the MOSFET and it goes through. And the board powers itself, so it's got a small amount of voltage and current coming out on one of those wires and then going back into the other when it's completed, and that's what trips it. And so I simply sent power from the Arduino Nano to that side that is looking for the current, the signal, and it tripped it. And I did that entirely wrong the first time and blew up a second Arduino because I wasn't actually sure how that worked, and I had it wrong, and so I was soldering onto ground as well as a pin, and that ended up feeding the volts from the MOSFET into the ground pin on my Arduino, and that of course made it pop smoke. So figured out how to get that to work, and it took me a while. I tried to use a larger MOSFET board first because we are putting 12 volts into 2 large motors in the backpack, and so I wasn't sure if that little board would be sufficient to handle that kind of current. And so I tried a larger one, but unfortunately that larger one needed more voltage or more current than the Arduino was putting out. The amount of power coming into the Arduino was enough, so if I connected directly to the positive from that step-down converter, it worked fine, but it wasn't working when it came off of the pin, despite the fact that the pin was high. But I switched to a smaller Arduino, or a smaller MOSFET board, and that took less voltage or current, and now it works perfectly. So power then comes out of our MOSFET to both to this jack, which goes to the backpack and makes the agitator and the blower spin, but it also then goes to our trigger switch, our firing switch. We also have negative from the main switch going to this switch negative and positive both come off of here to there, and that provides motor braking. So we have an electronic lock on this switch, which is that unless the rev switch is pressed, there is no power going to here. We then have a motor braking coming off of there. So negative and positive both go into this switch, and so when we pull the lever back here, you can see it makes that switch go, but that's one of the things that it's not returning quite far enough. It's unfortunately not, the spring on here doesn't have quite enough to pull that wire back that is that linkage. So I just need to add a return spring in there. But that puts motor braking on our pusher motor, which is important because we don't want it to slowly dribble one last ball into the flywheels if the flywheels have already been turned off. So I did just realize that the negative on there is coming through our MOSFET, and so it's entirely possible that this doesn't have motor braking if rev isn't still being pressed. But you shouldn't ever be letting go of rev before you let go of the firing trigger, but hypothetically that would be possible. I may want to switch that so negative is coming directly off of the main primary, so that this always has negative going through and giving us motor braking, regardless of the state of the rev switch. Though I think the negative on the other side is probably also coming off of that. I'd have to actually look at the wiring now that I think about it. But little things you work out as you go through this. It hasn't been a problem, it hasn't caused a problem yet that I'm aware of. Anyway, that is pretty much all of the circuit. So coming off of our Arduino, we have this wire here, which just jacks in. This is the signal wire that comes from the rev switch. So this is what completes the circuit and tells the Arduino that rev has been pressed. This single wire here is our MOSFET signal wire that trips the MOSFET. And then this one is the signal for the ECS. And it has 3 wires coming off of it. We're not actually using the center one. It's just, this was a pre-fabricated splitter that was exactly the right length, which is shocking. And so I didn't bother to remove that wire. It's just there. But that's really all there is to it. This isn't currently a terribly complicated blaster because I don't have anything like select fire or the ability to adjust the rate of fire or the power yet. I have plenty of extra pins, so if I want to set one of these so that I can have another switch where when this button is pressed, it'll change the FPS. That would be a very simple thing to do in the code. It would just be if this switch is yes, then RPM equals higher. If not, RPM equals lower. And that would not be difficult to do at all. I actually already know how to do that in the code. So that's really all there is to the electronics. there was then a lot of 3D printing involved, obviously. Let's zoom out and look at all the 3D printed parts on here. That's zooming in. So the entire back end from here to here is 3D printed in two parts. The first part goes up to here. Well, actually, it's multiple parts. But this back end of the receiver is all 3D printed and solid. I could have made it hollow and had more room, but I really didn't need it. I did end up having to reprint it because I hadn't made it long enough, and I didn't like where the cut ended up in here because the back end of this tapers, and it tapered too far, and so I made it a little bit longer so I could cut it right where the taper ended, and so it made it for much better integration there. I then did have to reprint this because I tried picking the blaster up by this handle and it cracked, and so the original one is around here somewhere held together with wood screws. But I reprinted it this time to have a hole going all the way through the handle so I could put threaded rod through, and so the threaded rod goes way up into here and then goes up all into here, so it's much more solid. This rod also I had to reslice to make hollow so that I could run that wire. That picture wire is what I think I'm using. And that's what connects our rear trigger to the switch. So this back here just pulls on a cable that pulls that switch. And unfortunately, like I said, it's not quite smooth enough so that that spring in that is just not quite strong enough, so I need to add a return spring. But that is fire. You pull that and it fires, and it's cool the way that works. Going to the front end, this assembly is also all 3D printed and involved a great deal of additional slicing because I needed to have the hole for the hose that goes in this side, as well as the section where the barrel on the tube on the inside of the barrel goes into here. I then also had to alter it so that there's chambers for all of the wires to go through, and all of that. I needed to make it a little bit wider because it needed to fit on this particular blaster, and so there was a lot of measuring and slicing and experiment and all of that. This little thing down here, I also designed and 3D printed because originally the hose came out the bottom here, and I needed an interface for that, and then didn't have doing that, so I just printed a cap and put that on there, and that solved that problem. Obviously, the cover for the switch down here, that's all 3D printed. Yeah, the other things that are 3D printed, the muzzle brake looking thing that I've made orange for obvious safety reasons, and then this tapering adapter here that kind of brings the barrel down a little bit. That I also managed to create entirely in my slicer, because again, I'm a toolless monkey. It does all use the, that's who I forgot to mention, Justin Sprecher. He designed the hose adapters for me that I'm using for this, which I've gotten some of my other proton packs retrofitted to use this. The goal is that I shall eventually be able to plug any of my blasters into any of my tanks using these exact adapters. And they'll all use the same cabling as well, so that the blaster, you can either run the backpack on a battery plugged into it, or you can run it off of a battery that's plugged into the blaster. In this case, the battery is in the blaster and feeds into the backpack rather than the other way around. And that wasn't entirely necessary. I could have made the blaster lighter if I put it in the backpack, but it made the wiring simpler because then I only have the two wires going back to the backpack instead of two wires coming from the backpack and two wires going back to the backpack and all of that, and it was just seemed simpler. So yeah, that's really just about it. A lot of cosmetic work, obviously, a lot of metal. So I used these brackets that are generally used for like shelving or whatever, flattened some of them out so that I could attach the shells together. Some of them I had to bend in order to attach the shells together. There's some just aluminum rod that I've hammered into whatever shape I needed in order to get it to fit where I needed. I am a big fan of using sheet metal and screws to hold integrations together rather than epoxy or Bondo or glue or whatever, because I just don't trust epoxy and Bondo and glue. They are brittle, they break. I'm sure people have said I've been running my blaster on epoxy for however many years and I've never had a problem. Lovely, that's fine. It's probably not 4 feet long on a gimbaled cam arm that's going to be slammed into by zombies. I wanted it to be a little bit more secure. And there are still points that I'm worried about. The barrel section is probably one of the weaker sections. This joint is probably by far the weakest section, though it's fairly strong, but not as strong as it probably could have been. There is metal that holds it in place, but not quite as much as I might have liked. But yeah, that's how it goes. That is how the blaster operates, and I am well pleased with it. The wiring is kind of looks messy right now, but you have to understand this is what it looked like when in its prototype phase. And then after I upgraded it, it looked like this. So I was able to clean up the wiring so much it's ridiculous. I'm absolutely pleased with how the wiring currently runs. Many of it is still modular. Obviously, the whole barrel section comes off, and then most of the things that are coming out here are jacked into something else back here that can be removed. Some of them aren't, but most of them are. So if I absolutely needed to be able to disassemble it further, most of the components can be easily removed. There's nothing soldered onto the Arduino at all. It's all using pre-soldered pins. The MOSFET board is all soldered together. But yeah, I'm very pleased with how it came out. Let's see. Did I manage to mention everybody? No, I didn't. There are a couple of people I still haven't mentioned their contribution. So like I said, Armor was the one who pointed out that I should use this blaster, and that's what got it all going. Once I had that, I was like, okay, I can do this, let's go. Zagadka had the bulk of the 3D printed files that I used. He had the whole thing modeled, and I sliced everything that he had. I sliced in one way or another. I had to make modifications to absolutely everything, but the link to his Thingiverse will be down in the description if you want to get your hands on these files. I did actually reach out to him to see if I could get the step files, because originally I was going to ask Justin Sprecher, my 3D designer, to hollow out his design so that I could just put internals into it. But we didn't have the step files, and so we only had STLs, and modifying the STLs in the way that I needed would have been very time consuming, and he was busy with school and life and other things. And so it wasn't until I realized that I had that blaster, and so the curator providing that was what made that possible. I spoke to Jesse at Project FDL as well as Airzone about how to get into brushless motors, because I had no idea how they worked whatsoever, and so I contacted both of them. Airzone was on through Discord, and Jesse through Facebook, and had some conversations on what I needed to know and what I needed to do and how to program the ECS and all of that. Out of darts, I got some of the material from him. I got like the motors and the ECSs and most of the switches and the Arduinos and a lot of the hardware I bought from him. Martin R1000 had some additional files that I ended up using. He didn't have the full Smartgun. He just had the parts that you would need to print to convert, say, an Airsoft MG42 into a Smartgun. So he had things like these, but I didn't like his design as well as I liked this one. But a lot of the muzzle brake was actually his. Zagadka's wasn't hollow, and so I couldn't put the barrel through it, whereas Martin R1000's was hollow, but it wasn't the whole thing. So I ended up slicing the two of theirs together in a weird way, but I was eventually able to come up with one that I liked, and that was the right size and that fit over that aluminum barrel. NPN, of course, was the cage, and then Ultrasonic, I got both the code, most of the code that I'm using from him, as well as part of the Flywheel cage. Then most of the rest of the mentions were people who helped with the filming. Sergeant Deplorable, Crewman Rocket, Crewman Luchathor, and Dr. Flux and his brother. So yeah, that is the build. For those of you that wanted to know how the inside worked, it's fairly straightforward. And then it just feeds from a standard proton pack. So, yeah. If you have any questions, feel free to ask them down in the comments. No, I won't make you one. No, I won't sell you this one. I also can't provide you with the files because they're not mine. I would have to reach out to the people that I got the files from if they, in order to redistribute the files that I created. But I'd be surprised if they wouldn't let me. And if they are willing, then the crew does actually now have a Thingiverse page. So I would be able to post my files to that Thingiverse. So I will look into that if anyone wanted to make one of these, because I would love to have multiple Smartgun proton packs at an HVC someday. That would be wicked. Okay. I now need to make the couple of alterations. I need to alter the jam door slightly, and I need to add a return spring to that. I'm thinking an extension spring would probably be the easiest way. Success! I have added a tiny spring. Now I just need to make sure it doesn't pop off of that. Do I have any tiny... Yes. 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 For a tiny nyat. Alrighty. Lovely. 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 Return spring added. Okay, that leaves us with tube issues. We shall solve our issue with the drill. And there we go. Now it fits without any tension on it. So we shouldn't have any trouble with feed. Flip, dust, 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 dust. Okay. Let's put it all back together.